All right, today we're talking about lesson 7.1, solving linear systems by graphing. If you look at this picture, that little smiley face is where the two lines intersect. Okay, now, while we're at it, let's talk about this. If you've got two lines, we've got three options. They can be parallel. There will be no solution because they don't touch, they don't cross. Parallel lines never intersect. You could have intersecting lines. How many solutions do you think they have? One solution, and it is where they intersect. And then the third type of line, and this is one that really goes unnoticed. People don't really think about it. I got a line here. And then I got a line there. Two lines that are basically the same line. They lie right on top of each other. How many points do those lines share? An infinite amount. So this would be an infinite solution. That's it. That's a terrible looking mess. Yes. One solution. So, when you are solving a system, it's basically a system of lines. It's two lines. And when you draw two lines in the same plane, you've got three possibilities. They are parallel, which would be no solution because they never touch each other. They intersect. Perpendicular is in this intersecting, right? It's where they touch each other or cross each other or intersect. It's got one solution and it's that point. Or the lines lay right on top of each other. They're basically the same line and they share every single point on the line. That would be an infinite solution set. All right. So, two or more linear equations form a system. Right here are pictures of what we just talked about. They intersect, there's one solution, it's right there. Parallel, no solution, or they're the same, there's an infinite solution. And if they are in slope-intercept form, it is very easy to figure this out. Because if they have different slopes, they intersect. Same slope and different y-intercept means they're parallel. Same slope and same y-intercept means they're the same line. So if they're in slope-intercept form, it is quick to see what the solution will be. Now, you might have to actually solve them for a minute. All right. Now, we're going to solve these by graphing by hand, which I'm going to tell you right now, I am not a fan of doing this by hand. Why? Because what? It's not accurate. It's not accurate. Okay? But you could do it. So, we're going to be as neat as possible. First of all, these are both in slope-intercept form, correct? Are the slopes the same or different? Different. So we know the lines are going to intersect. So how many solutions are there going to be? One. So let's graph this first line. The y-intercept is -3. 1, 2, 3. And my slope is 1/3. Up 1 and over 3. Up 1 and over 3. Up 1 and over 3. I'm going to try and graph it as neat as possible. I'm going to draw my line. Oh, you can already tell that my line is not straight, which is why this is not an accurate method. Okay, line 2, I'm going to change colors. And you know what I'm also going to get in the habit of doing? Guys, on a quiz or a test, I will want you to label this line. This is the line. Y equals 1/3 x minus 3. So it's clear to the viewer that you know that that is that line. Our second line, I'm going to change colors up here to make it even nicer. My y-intercept is 1, and my slope is -1. So if I write -1 as a fraction, won't it be -1/1? So let's go. Down 1/1, down 1/1, down 1/1. Now look how nice that is. Down 1/1. Didn't they intersect right there? I'm going to label this as y equals -x plus 1. Is everybody following me? Now, for graphing purposes, this one worked out great by hand because they intersect at a major intersection, which is, i.e., whole numbers. Okay? And it was easy to figure out because when I did down 1/1, up 1/3, weren't they both through that same point? What is that point? It's 3. What? 3, -2. Okay, so they both go through the point 3, -2. Now, if I say to prove it, watch what we're going to do. We are saying that this point right here lies on the blue line and the red line, correct? So, I'm going to take this point and I am going to substitute it into both equations. So, this is x and this is y. So, I'm going into my first equation. Y is -2 equals 1/3 times x, which is 3, minus 3. What's 1/3 times 3? 1. So I'm going to have 1 minus 3. What's 1 minus 3? -2. Is that point on the first line? Yes, it is, because when I substitute it in, it makes the equation true. So it is on the blue line. Let's prove that that point is also on the red line. So y is -2 equals x. It will look like say -x. So -3 plus 1. What's -3 plus 1? Does -2 equal -2? Is it on this line? Is that point on both lines? Yes, it is. So that is a solution to that system. The lines intersect, and the system is solved at 3, -2. Yes? Now, let's get your graphing calculator out. Where's my graphing calculator? You got to bring it with you every day. Where's my calculator? There it is. Is helpful. We are going to do the same exact problem on the graphing calculator. The hardest part of these problems is that you need to transform into slope-intercept form accurately. Because if you don't do it accurately, you're going to be typing in the wrong equation and it's going to give you the wrong answer, right? So, we're going to do number 1 again. Go to your y equals menu, upper right. Y equals x plus 2. Enter. Oh, that's not the one that we just did, is it? Okay, so watch how you have to enter 1/3 x. Put parenthesis 1 divided by 3 parenthesis x. Make sure the coefficient of x is in parentheses if it is a fraction. And what was it? -3. What was our second equation? Okay, guys, look at me. See this negative down here at the bottom? Do not use the minus, use the negative. So negative x plus 1. Now, I'm going to go up to the graph button and hit graph. There's your first equation. There's your second equation. Now, hold on. Stop the bus. Do you start looking and try to count that out? No. Your calculator is going to tell you the actual point of intersection. If you can't see the point of intersection, what should you do to your window? Adjust your window. Expand it. Okay? So, you are going to go, do you see this up here? The calculate button? It's right above the trace. So, second, calculate. 5 is intersect. So, either scroll down to 5 or hit 5. Now, okay, hold on. Okay, hold on. Don't do anything. Stop. I'm waiting for Dalton. What is your window set at? Okay, so hit graph. I think you might have changed the line color. I don't know. We'll look at it. All right. So, first curve. By the way, look, guys. Hey, stop talking. Do you see this flashing cursor? It is on the first line, which look right up here. Y equals 1/3 x minus 3. Hit enter. See how it jumps to the second curve? That's negative x plus 1. Hit enter. Guess? No, we don't want it to guess. That's dumb. Hit enter. What's the point of intersection? 3, negative 2. Do you see that? So, second, calculate, 5, enter, enter, enter. All right. Let me pull the notes back up. Yes, what's wrong? Hold on, let me pause this. Back to the notes. Good. Let's look at number 4. Look at number 4. Solve the system by graphing. What form do we want to get them in first? Slope intercept. So, how do I get the first line, this top line, into slope intercept? What do? Subtract 2x from both sides. So I'm going to have y equals negative 2x plus 2. Correct? What do I do to this one to get it into slope intercept? Subtract 2x. So I'm going to have y equals negative 2x minus 2. First of all, tell me about those two lines. Who can tell me about those lines? They're parallel lines because they have the same slope but different y-intercepts. So what's the solution going to be? No solution because they don't intersect. So our first line, my y-intercept is 2. My slope is negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And I'm going to draw my line, and I'm going to label that line y equals negative 2x plus 2. I'm going to change colors. If you are somebody that likes to use colored pencils, tonight's going to be the night. My second line, my y-intercept is negative 2. And my slope is down 2 over 1, down 2 over 1, down 2 over 1. There's my second line. I'm going to label it y equals negative 2x minus 2. And I'm going to write no solution.